Hello there, my mate Vince here, and in this video today we're going to try to fix up this DJI OSMO Mobile 6. It is a smartphone stabilizer and it is a current product currently for sale in the shops for around £135. You can see Amazon and Argos there. This came to me as part of an Amazon return box and the fault is quite interesting, so I'm going to take it over to the mat now and show you what the fault is.
It doesn't turn on here. It's supposed to press that down there to power up, it's not doing anything. Weirdly, maybe it's fully charged, but when I plug it in here, it seems to charge for a second and then drop out. Watch, we'll go to 0.50 or something, and then down to nothing. And I'm not sure if the batteries were full, if it would drop out that quick. So can you see it goes to nearly 0.7 and then down. If I leave it, it won't. See, then that's weird. It actually went off there completely, as if it's like a sort of short or something. I don't know. It's not killing it. It's just going to zero. But why at the odd time does it turn itself off? Unless, of course, this is turning itself off. Don't know. Right, problem with this is that there is no teardowns from what I can see of this particular model, and also it hasn't come with this magnetic mount at the top that you get your phone to, attach your phone to, but that mount is apparently £19, so it's not the end of the world. So, having a look around, it extends up like this. There is 4 screws here, little Torx screws. Let's undo these. Well, it looks like it's the T4 that fits. Now, so that comes up there. Can't see any more screws there. I wonder now, is it just going to prise out from here? Maybe. I wonder, is there screws hidden in the bottom here as well? Yes, there is a load of screws here as well. Excellent. And these are little crosshead screws. Okay, that comes out there. I can see a blue battery in there. So now I'm hoping it will separate. There we go. Right, it wasn't awful, but it wasn't easy. So there's clips here and here, and yeah, so there's 2 clips here and here. So yeah, not too bad actually. It was just this sticky thing here which is making it stick to that. So now, that goes all the way up. That's the main feed going up there. That's soldered onto the board there. Let's see what's going on. That's just for the trigger. Oh, and the charging as well, the trigger and the charging. Let's take this little board out. Right. Let's zoom in and see if we can see anything. So I suppose first things first, let's unplug the battery and plug it back in, just in case it needs to be reset. So that's unplugged. I wonder, can we measure voltage on the battery? I'm going to go across the red and the blacks. Oh, 8.2 volts. Maybe it is fully charged then. 8.2. Oh no, it says here 8.9. So the battery isn't fully charged, so it's not charging. Why? It's not charging. Let's zoom in and have a look at this USB-C port. 8.2 would still be enough to give it power though, wouldn't it? Right, okay, that looks okay. I wonder, can we see? Because this should be just giving it power. Nothing else should be happening here, should it? Right, that's connected to there. That lifts up. Right, okay, so once you get rid of the glue, that will pull out. Well, that looks like it's in properly. And down there as well. Looks like it's in properly. What else have we got going on? Board's labelled up here. DJI. That's all glued down. It looks all incredibly well made. Alright, well, I'll tell you what we'll do. Let's plug it in without the battery and see what happens. Right, let's plug it in here. See what it does now. Right, so it cuts itself again, even without the battery plugged in. It doesn't go as high on the amps, but it still cuts itself out. And now look, it's turned this off. It's weird. So have we got shorts? Just go to continuity a minute. I can see two caps down here. And no short on that one. Ooh. There's a full-on short on that one. I'll zoom in case my leads are touching. Right, you see that bottom cap there? Right, so I'm not on that one, I'm there. There's a short, isn't there? Right, let me go to ohms and read out the ohms reading. Right, 0.7 off an ohm, and when I put my leads together, 0.3 off an ohm. Yeah, that's a short. So now, where does that go to and from? What are these things here? What are these, just big bits of rubber? Let's take this off. Don't know what's going on with this. Let's take it off. So, is that glue on there? Or is that some sort of damage? It's probably just glue. Feels a bit crusty. I wonder whether that capacitor has shorted, and this is the chip. I'll tell you what, let's pop this board out, if I can. And let's just remove that cap with hot air. You never know, we might have gone straight onto the faulty cap just by luck. Actually, how am I going to take this out here? How does this come out? Oh, there's a circlip. There's a circlip holding it in here. Do I want to get involved in that? I think I'm just going to put some hot air in here and try to... Or should I just try to break the cap off? Mind you, the cap might not be faulty. How much things am I going to melt? Let me zoom in. I think I might be okay, as long as I keep the air very close to that. So I don't want to use low melt solder because I'm just going to end up getting it everywhere. Right, I'm just going to blast it with hot air, take that cap out, see if the short is still there or not. Right, that is off.
Now, while we're waiting for my deafening air station to cool down and be less noisy, let's have a word from today's sponsor. So this video today is sponsored by... PCB Way! I thought I had perfect eyesight until I compared my eyesight with somebody who's got failing eyesight and their eyesight was better than mine. age.
PCBWay have over a decade experience in the PCB industry. They have state-of-the-art manufacturing facilities and they use the latest technology to produce high-quality PCBs that meet your specification. At PCBWay, they have a range of services including PCB prototyping, PCB assembly, flexible PCBs, high-density PCBs, CNC machining and 3D printing. So if you need your project to be lightweight, for example a drone project, then you might want to look into flexible PCBs. Not only are they lightweight, but they're also space-saving and they can withstand extreme temperatures. So they might be a better fit for your project over rigid printed circuit boards.
So as always, I'd like to thank PCBWay for sponsoring the My Mate Vince channel. Now, let's get back to this phone stabilizer. I already feel more intelligent, not stereotyping.
Right, meter on continuity. Oh, annoying, you're still there. You're still there. Right, okay. Right, let's just go on to the cap itself. Yeah, there's no short there. Right, okay, maybe it was just a bit of crusty glue on top or a bit of flux or something. Right, let's zoom in and see what else it could be. There might be something on the other side of this board as well. Unless we were to put a bit of voltage injection in, and then it might bring something up. I wonder, can we work out what side is the actual ground? So, that's the black wire here. Let's see what's happening here. Right, so that's the ground side. So that's the ground side. So this is the live side here. Yeah. Let me just get an ohms reading. So I'm just using the negative of the battery. You know, these terminals here would be the negative ones because they're the black ones here. So now, this side here is 1.2 ohms currently, and this side is 1.8 ohms. When I put my leads together, 1.24. Yeah, okay. I mean, I'm assuming it is going to be a short because it is very it's very low. I wonder, is it this thing here? So hard to see where it goes on the board, but it looks like it goes to that one there. I'll tell you what, let's add a tiny wire to it and we'll do a bit of voltage injection. Really, I think I do need to get the board out here, unless it was going to be that little component there. But at this moment in time, I can't even see what it says on that component. Right, they are just barely balancing on. Obviously, this is all incredibly small, so it's hard to get bigger wires onto small ones like that. I'm just going to put 1 volt in here at, I don't know, 1 amp or something like that, and we'll see with the floor cam if anything gets warm. I'm suspecting it might be that little chip there. Maybe that's some sort of voltage regulator chip. Right, so this is 1 volt at 1 amp. So let's connect up the negative. Let's see what's going to draw. Yeah, straight to 1 amp, 0.7 off a volt. Hold on, slightly confused. Heat seems to be everywhere. Right, well, there's nothing conclusive there. It just seems to be all over the place. Let's turn off the power. Maybe it's the other side of the board. I'll tell you what, let's try to take this board out. So I'm going to undo that circlip up here. It'll probably go flying. Right, that came flying out, and now we're off. Well, you never know, it might be something on this side here. So let's solder that little wire on again and we'll flip it over. And we'll have a look what's happening on the other side. Right, again, 1 amp, 0.66 volts. Now you can see when I put my finger in the frame there, that is my finger, that's the lightest by far. There's nothing short in there. Let's turn it over. Again, when I put my finger in the frame, there's nothing short in. The reason I'm putting my finger there is because everything will look bright without my fingers. But when I put my finger there, then you can see now that the board isn't as hot as my finger. What a shame. I wonder, is it this chip here, BQ? That looks like some sort of charged chip, doesn't it? Bet that chip's shorted. Tell you what I'll do, shall I take the chip off and then see what... see if the shorts go away. Yeah, everything's shorted here. I mean, if we took the chip off and the short's still there, it might be great because it could be one of these caps. But you would think if it's, you would think 1 amp at 0.7 volts would do some kind of heat spot on it. Right, what I'm going to do is I'm going to put IPA on this area here, and I'm going to attach the leads directly to here. So I can see that this here is going to be the ground, and that side's going to be the live. Let's see if anything melts off. There's nothing getting hot there at all. I'm wasting my time. Right, let's... should I take the chip off? Right now. Let's see. No way. No way, it's still here. So let's just take off these components here. Let's take off all 3, and let's see if the short disappears. I mean, it's good news that the chip is that the short is still there, because you never know, it still might be a capacitor issue. Wouldn't that be amazing if it was a little capacitor causing this? I'm just confused why it's not showing up on the flare cam. No way, the short's still there. So let's go back over this side. What else have we got left? 2 shorts over here. So it's this rail here. Let me take off this little chip. No way. It's still there. What? Hold on a minute. Right, this goes to here, yes? Not short into these ones. Where on earth is this short coming from? I've taken everything off. Right, let's get some IPA. Let's take this off, just in case it's travelling down to the motor and the motor's putting some kind of weird short on it. I thought I'd be able to find the short, but no. This is beating me. Right, I've taken a picture of this because the labelling here is all over the place anyway. B there, green, W. Well, I'll tell you what we'll do. Hold on. Before we unsolder them, let's see if we actually have a short on here. See if they're linked to here or not. So first of all, let's go between here. So those two, there's no point in taking them two off, but these two are shorting. Now, was that it all along? Here and here? It could be, couldn't it? Just take off one at a time. Interesting. It's gone. Yeah, it's gone. So has this red wire put a fault on it? Well, that would have been a lot easier than taking off all the chips, that's for sure. Let's see now. Yeah, so that's shorting and that's shorting. Okay, what I'm going to do is I want to unsolder that. Let's just leave it like that for a moment. Let's put everything else back on and see then if we have life in it. You know, if the light comes on, then we know it's a problem with the motor.
Well, you know, I didn't think that the fault could be travelling up the wires here. I was concentrating purely on the board. I suppose the problem is I just didn't think, did I? I should have trusted that the FLIR cam was going to be correct. I should have trusted that the IPA would have shown up heat in a component. We know we've got shorts and there isn't that many components here, so if it was that little voltage regulator or the chip or one of the caps, it probably would have showed up at 1 amp at 0.7 volts or whatever it was, something like that, because you see they're not massive components like an APU or a CPU that's going to be draining all the heat away. So yeah, I'm looking back at this video now while editing it and thinking, yeah, that was silly. I should have maybe taken that glue off to begin with, just to see, you know, to eliminate boards. Because then if I had eliminated the boards, then I would have saved so much time, because I've spent quite a bit of time taking all the chips off this board here. Anyway, I'm putting them all back on. It's not a hard job to do. All these chips are relatively easy to do, even though they're small. There is a fair bit of room around the place, so it's not too bad. Anyway, it gives me a good chance to shout out the My Maintenance Massive. So the massive members this month are KipDigital.com, Kip Hakes, Max Rokotansky, Having Fun Repairs, Chris Seal, Felipe at MrKeebs.com, DJ VG, Pigsy, Robert from Timsy's Auto Air, Anthony Dean, Bazza2, Russ Melanson, Gaspar Heller, Rickard Bergland, Jacob Colpin, and Soul Reaver 555. So many thanks to each and every one of you. So we pick up the video now when all the chips and capacitors are placed back on, and I'll piece things back together to see would it turn on now without that faulty wire that's going up to, I presume, a motor.
Right, so that's them all soldered back on now. Really, it makes sense why, you know, this is the most likely thing to fail. I just thought it might be a capacitor. Now let's push it back together. Now let's see if it's going to charge. So both these wires have come off now, the red and the yellow. Let's see now what happens when we try to charge it. It's very hard to work on because everything's so small. Oh, lights are on. Look at that. No way, the lights are on. Right, off. Let's see if it turns on. Yes, it does. It turns on. Wow. Okay, turn it off. Now, let's see if it charges now. Green light's flashing. Yeah, green light's flashing. 1.75 amps. Interesting. Okay. Well, it doesn't look like I've caused any damage by doing those chips, but I won't know unless I do actually fix it. So, what is happening on this motor up here? Let's disconnect everything. So it's something on the power, not on the data, because these two look massive. These two wires look big, so it looks like it's a problem on the power. Right, let's... can I unclip it from there? Should be able to. Oh, it's glued in. Right, so it's on a curly cord going up the middle there because it's expandable. So I need to get really into this, I presume this top one here. Or it could be any one of them that's putting the fault on, couldn't it? It could be this one up here. This looks like the easiest one to come off because it looks like it's got a little plastic cover. So there must be interconnecting ones on each of them. Well, it's not going to be on the lead. It'd be highly unlikely that the lead itself is shorted because this looks brand new. I suppose realistically, would it be in this one here then? Okay. Whoa. Right, what have we got going on here? Fancy. Very complicated. So this allows it to spin here. All the wires come up to here. Right, let's see if it at least marries up here in case it's faulty from manufacturer. So red goes to red. Down here, what did it go to? Red goes to red. Yes, I think it was. Blue was to yellow. Blue was yellow, yeah. Violet was green. Violet's green. And green is white. Whites, yeah. Okay, right, well what we'll do is, luckily, I'm glad we started at this one. There's a little connection here that goes up to the next one. So if I can pop this connection off without breaking it, then it means then it will prove the fault onto this board or further up. I'm not quite sure what's happening on this thing here. Again, it's been glued down, which is good because there's less chance of it coming apart. It's just harder to fix. Well, that's annoying. I took it off there. I also took off the lid of the inductor, but I think it came off so cleanly. I think it is just a plastic lid, and I think it will go back on okay. If you have a look here, can you see that we have one nice inductor here, here, and here. I don't know if it's an inductor or a resistor or whatever, but that one hasn't got the lid on. And if I look really closely, I can just see the lid just here, just there. Anyway, now that we have that disconnected, let's solder back on the wires here and see if it still powers up. If it still powers up, we know then that the fault is further up into it. Right, let's see now if it will turn on. No. Right, so it looks like the fault's on this board here. Right, so we've got a short between the yellow and the red. Unfortunately, I can't really see where they go. Yellow and the red. Well, I wonder if we unsolder this, will it allow us to take the board straight out? Slightly worried about these wires here, you see. They're going to be connected to the motor, so I won't be able to take the board out unless I undo them as well. Right, so it's not the wires themselves, which I thought it wouldn't be, because there's no short now that I've disconnected the red one here. So the fault is between the yellow wire, which is ground, and the actual pad itself. Unless maybe it's this motor here which is putting the fault on. Right, I suppose I'll try to unsolder them if I can. And it's incredibly difficult because it's got to be upright. Right, that's 1 free. 2 free. Excellent. Right, now let's see if the fault's gone from the board, because it could have been these wires here that were putting a fault on. No, the fault's still there. Right, so it's something on this actual board. Interesting. My money is on that big chip there. Oh, good. They come out of the holes in different locations, so I don't have to worry about that. Right, let's fault find this board. So I wonder, are the capacitors around this chip shorted? No. That one is. Yeah, full short. Well, should we put a bit of voltage in and see what gets warm here? Why not? So the reason the flare cam didn't work before is because the short wasn't on that board, it was up here. So this is a negative, this is a positive.
So again, I'm going to inject voltage at 1 volt and 1 amp. We'll see now if anything gets warm.
And it's drawing 1 amp. Come on now, flare cam, be good to me. Come on now. Oh yes, something's getting warm, something's getting warm. Excellent. This thing here, what is this thing here? What is this thing here in the middle? Oh, I don't think it's the chip. Oh my God, I think it's that capacitor. I think it is the capacitor. No way. Right, let's put some IPA on it and see if we can see it. Imagine if it was just a capacitor. I haven't had a capacitor fault in ages. Let's put some IPA on it and see if we can see it burning off. It's got a crack through it, hasn't it? Unless that was me scraping it. Annoyingly, I can't really see it burning off. Well look, the flare cam did pick it up. My finger's not really picking it up though. Let's turn off the bench power supply. Let's get some hot air on that. Let's take off that capacitor and see if the short disappears. Got to be careful that I don't burn this connector here. I'm angling the heat away from it. Right, here goes, meter on continuity. Will I get a flare cam fix and a shorted capacitor in the one video? That would make my day. Come on now. Please don't be shorted. Oh my, 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 my. Oh my. Oh my God, oh my God, oh my God. Bring the capacitor over here. Have I really had a capacitor fix? No. What? What? Why are you not shorting? Why are you not shorting? No! There we go, that should be clean. I'll turn you over. Right, let's see now. Is it gonna beep? You beauty. Oh, you beauty. How good is that? Ah. Life does not get any better than that. FLIR cam and shorted capacitor in the one fix. Amazing. Right, okay, I have now got to put this back together. What am I going to do about that capacitor there? Should I just put on a 100 nanofarad? I haven't got a clue what it's going to be. There's no other capacitors in parallel with it anywhere that I can measure. Let's just stick on a 100 nanofarad, and then I suppose it's better than having nothing there. So I'm going to stick this one in 100 nanofarad. Obviously, I have not got a clue what the capacitor should be. I'm only doing that because they're quite common on other things, but it could be any one of these values down here. I really, really don't know.
It's probably been about a month or so since I filmed this video. I'm watching it back while editing. I'm still on the high to have a capacitor fault coupled with it being detected by the FLIR cam. That is unheard of for me, and it's just so nice to have a FLIR cam fix, worth its weight in gold when it works like that. So I just need to solder the new capacitor back in. It is a little bit on the big side. I should have used a size down, but I haven't actually got any that small, but it does fit on the pad, so it's okay. It's not shorting anything. And then I just need to put it all back together, give it all a bit of a clean up because there's a lot of flux everywhere, and then we can do some testing. So hopefully next time you see this now, it will all be up and running. A capacitor fault is so good.
Right, here goes. I promise I haven't turned it on. So looking at a review, I think you can turn this and it will turn on. Oh, yes, you did. You turned on. Right now, what do you do?
Well, there's going to be a bit of a steep learning curve on this one because it does so much. But first thing I need to do is buy the magnetic mount for £20 from Amazon because it does not work without it. You have to have that as far as I can see. So the next time you see this, hopefully I will have the mount in my possession and I will have my head round how this thing actually works. Right, it's been a while later now and you can see I've got the mount at the back here. Watch this. If I double tap the button at the bottom, it will recenter itself. Let's bring this in so you can see it easier. This thing does so many things. So watch this. If I was to tap this button once, it will go between forward-facing camera and rear-facing camera. Tap it again, it will go back. If I do it twice, it will go portrait to landscape and landscape to portrait. If I do it 3 times, it will go video to photo and photo back to video again. So if I was to hit this button here now, it will take a photo. And likewise, if I was to do it on video, it will take a video. So we're now recording. Does lots of other things as well. If I was to get this into frame here, so let's recenter it by hitting the trigger twice. There we go. If I get that into frame, let's move it up a little bit. And if I hit the button at the back once, I'll get a green box around here now. And now it will try to keep that in frame. So you can see when I'm moving it here, it's keeping it automatically in the middle. Also up and down as well. It's clever, isn't it? And now watch this. If I hit this button and go to, I think it's lock. Tilt locked. Now if I hit the button at the back, can you see? It will keep it. It will keep it locked like that. That feels so nice. Other things it does is you can obviously move it around on the joystick, and as well, check this out, you can do the focusing here. Now this camera has this phone's got 3 cameras, so sometimes you will see it jump, but that's on one camera. Now it will jump to another camera. There you go, jump in. But you can see I'm zooming right the way in using this little thumb wheel. So it is all working absolutely perfectly. So it all went faulty because of one capacitor. How good is that? So yeah, thoroughly enjoyed this one here, and it's a very intelligent little product. So yeah, it feels nice how it works. If you enjoyed the video, give it a massive thumbs up, and I will hopefully see you all very soon. Thank you so much for watching.
On the floor, looking up, wanting more. This is so unreal. I must have been